So in this video, we are trying to find the intersection point between two lines. So in this case, we'll look at the line with parametrics line. Second, we'll look at symmetrics with symmetrics line. And the last one, we'll look at parametrics and symmetrics line. So we're going to find the intersection point between these both lines. So first, let's look at the parametrics and parametrics line. Means that both lines are in parametrics form. So you can see from here, example 5, given that the line L1 and L2. So if you want to find the intersection point between these two lines, which is both lines are parametrics equation. So we will equate x with x, y with y, and z with z. So from here, we'll get the t in terms of s. So after that, we substitute and we can get the point. Let's straightforwardly look at the exercise 5. Let's say in exercise 5, consider the two lines L1 and L2. Find the point of intersection of two lines. So this one. So for L1 and L2, x with x. So x compared with x. So means that 2t is equals to 4s. So t is equals to 4s divided by 2. T is equals to 2s. For the second part, y and y. So means that negative 1 plus 3t is equals to 5s. So 3t is equals to 5s plus 1. So t is equals to 5s plus 1 over 3. So let's say here is equation 1. Here is equation 2. If we substitute equation 1 into equation 2, we should get the value of s. For example, substitute equation 1 into equation 2. Since t is equals to 2s, so here is t. So here it means that 2s is equals to 5s plus 1 over 3. Multiply 3 to the left hand side. I should have 6s is equals to 5s plus 1. So from this part, 6s minus 5s is s. S is equals to 1. So from equation 1, we try to find the value of t. So since t is equals to 2s, so here t is equals to 2 times 1. T is equals to 2. Now we already have the value of t and s. We can substitute into L1 and L2 to find the x, y, and z coordinate. Let's say from L1, x is equals to 2t. Since our t is 2, so x is equals to 2 times 2, x is equals to 4. And then from y, y is equals to negative 1 plus 3t. So negative 1 plus 3, t is 2. Negative 1 plus 6, this is equals to 5. And then z is equals to 1 plus 2t. Against our t is 2. So 1 plus 4, which is equals to 5. If we base on our L2, line 2, x is equals to 4s. Against our s is equals to 1. So x is equals to 4. For y, y is equals to 5s. Where our s is equals to 1. So 5 times 1, y is equals to 5. And then finally, z is equals to 5s. So z is equals to 5 times 1. Z is equals to 5. You can see here, you can notice that x, y, z from the line 1 also equals to the x, y, z from the line 2. which is x is 4, y is 5, z is 5. Therefore, the intersection point will be equals to 4, 5, and 5. So this is the answer for exercise 5. In the next video, we'll look at the intersection point between symmetric equation and symmetric equation. Both of them are symmetric equation. In the first example, both lines are parametric equation. So in our second video, in the next video, we'll look at when both of the equation are symmetric equation.